Good morning. I am Pokimoner, and today I'm gonna presenting about my independent study on IoT OS and open source operating system built for very small Internet of Things device. Over the next 10 minutes, I will show you why the billions of the microcontroller can run Linux and how IoT microkernels, real-time scheduler, and energy-aware design solve the problem, and where it's already deployed in a smart city, factory, medical wearable, and architecture. I will compare IoT to Contiki, NG, and TinyOS. Highlighted is the advantage and finish with the key takeaway or summary and some questions. So let's start. IoT growth is staggering. Analysts forecast a 30 billion devices by 2030. Most will be powered by microcontroller with only a few kilobytes of RAM and flash, running off coin cells or harvesting energy. Full Linux or even Zeppelin footprint are far too heavy. Yet we still need multitasking. IPv6 and security IoT OS was created precisely for this gap is squeezing a real-time scheduler, full network stacking, and toxic-like API into under 5 kilobytes of flash. That efficiency makes the developer no longer sacrificing features or resources to duplicate bare metal code when building the next generation sensor and wearable. IoT is built on a microkernel, only the scheduler, IPC, and interrupt dispatchers live in the privileged mode. Driver, stack, and app run as an unprivileged thread, improving isolations and configurability. Preemptive multitasking support portality, mutex, and the message passing, letting the timing critical tasks meet the deadlines under the 50 microsecond on a Cortex M0. The developers program in standard C or C++ with a lightweight C++11 runtime. A simple kconfig style system compiled of unused model. So IoT mesh match each board's memory budget of today and more than the 250 ARM, AVR, and ESP32 and RISC-V board run IoT. That's proving its portability. Battery swap and truck loads are costly, so IoT emphasizes energy saving. A tickless kernel remove priority timer interrupt, allowing the MCU to enter its deepest sleep until a true event occurs. High resolutions around wake the CPU exactly when needed. Flexible power scattering turn off the idle SPI, IC or ADC block automatically for energy harvesting node. The IoT export the real-time voltage, so the application defer work when the capacitor is low. In a published soul sensor study, Identicious hardware running IoT lasted 40% longer than a Contiki NG, while providing the same 1 minute sampling rate. IoT GNRC stack is fully modular and standard driven. At the link layer, you can select IEEE X02.15.4 or Bluetooth LE, LoRa, or sub-gigahertz 6-row PWPAN compressed with a IPv6 header enabling IP on the 127-byte radio. RPL handled the multi-hop routing in loosely meshed. Transport options include UDP and a minimal TCP. Applications protocol provide a Core AP and MQTT-SM. Also curable with the DTLS, this standard comprises mean IoT sensors appears on the wider internet like any IPv6 host. That means no probability gateway. Border router on the Linux or OpenWRT simply forwards package, ensuring the long-term interoperability. TinyOS is memory frugal but written in NetC and statically event driven, which complicate timing and onboarding. Contiki NG improved that the language familiarity with C and at 6 low WPAN, yet still lack preemptive thread and deterministic latency. IoT strike the balance a microkernel plus configurable modulus keep a RAM within the 2 kilobyte of the contiguity, while the driving full of the POSIX thread and the hard real-time support. Build tooling is the standard of the GCC and Make is the ideal for the modern CI pipeline. Also, we're talking in short that IoT is to combine the developer productivity, that's the executions determinism, and memory efficiency better than its lightweight peer. IoT already run in driver's deployment. Lion Smart City project used the 500 air quality node with failure rate under the 3% over 18 months. Bunch retrofitted factory converted with the RIOT vibration sensor that predicted bearing the failure 6 days earlier. A German startup built an ECG patch on IoT and BLE. Critical thread show 5 days runtime on CR2032 while encrypting all the data. In Brazil, IoT soil problems trigger drip integrations only when the moisture is low, reducing water use by 25% across 10 outage. These cases prove that IoT is reality in the city, industrial, and the medical and architecture domain. And for the summary, IoT shows that the capability doesn't have the exist footprint. It overly looks like abstractions, thread, socket, shows on MCU costing under $2 and running for years on a battery. That is tickless. The powers aware the kernels extends operations life is IPv6 native stack guarantees the future network compatibility, and its open community governed code base accelerated innovations while avoiding the vendors lock-in. If the turns of the sensor are coming, they need a solid foundation. The IoT's positions itself as the Linux of IoT, enabling fast prototyping for engineer, longer device lifetime for the business, and smarter and have a low power environment for user too. And for our questions, I have three questions. For the question one is why IoT over the Contiki NG? And my answer is IoT at the pre-impressive multi-trading and real-time guarantee while keeping a tiny footprint critical for time-sensitive industrials and medical IoT.